Okay guys, Timmy coming at you here again, and today what I'm going to do is I'm going to be going over calcium, hypo and hypercalcemia. A couple of things, and again, if I say it about a million times, then it's really important, right? So remember, the most important element in muscular contraction is calcium. And remember that the heart and arteries rely on calcium from the blood to contract. Skeletal muscles don't. Skeletal muscles store their own calcium. Right? So where do skeletal muscles get their calcium to contract? From inside. It's inside. So blood levels of calcium do not affect skeletal muscles directly. They affect the nerves that stimulate skeletal muscles, but they don't affect the calcium that's stored in skeletal muscle. So when you think about calcium, just like you thought about potassium, you think two systems. You think the cardiovascular system and you think the nervous system. Those are where you are going to get the most profound effects when blood levels of calcium are high or low. Now, the other thing you got to remember is the only type of calcium that can affect the cells of the body is the free-floating type. So in your book, there's ionized calcium. Ionized means free floating, right? There's another way, and a lot of electrolytes are transported this way, is on that big freaking protein albumin. So if you recall when I talked about buffers, one of the chemical buffers in the body, boy, is albumin. And one of albumin's functions is to transport calcium around in the blood. So the little albumin bus I talked to you about. So total calcium is the amount of free-floating calcium or ionized and the amount of calcium that's bound to albumin. So anything that affects the amount of albumin in the blood is going to affect the amount of total calcium that you have floating around in your blood. And remember, the body does stuff that makes sense. So look, watch. Hang on here. So where do you store most of your calcium? I apologize for the drawing. Right? You store it in bone. Right? 99% of all your calcium is in bone. What we're talking about is calcium that's in the blood. Right? So the body again does stuff that makes sense. So let's say, for example, that your blood levels of calcium begin to drop. Who cares why? Would it make sense that the bone, right, where you store all your calcium, would it make sense to break down that calcium that's in your bone by these little cells called osteoclasts? You learn this? Osteoclasts break down bone, and then they break down the bone to calcium and phosphate and then dump the calcium in the blood. Well, you know, that takes time, right? It's not instantaneous. Or would it make more sense that if something happened to the amount of ionized calcium floating in the blood, it decreased? Who cares why again? Would it make more sense to have floating around in your blood a readily available source for calcium, right? Would that make more sense? And to me, that makes more sense. So what allows the calcium in the blood to remain pretty stable is our buddy, our pal, big L, albumin. So if the blood levels of calcium begin to drop, and remember, only the free-floating or ionized calcium affects nerves in the heart, right? If it's bound to albumin, it doesn't have any physiologic effects. So if the blood levels of calcium drop, then where do you have a little extra that's not free-floating? On big L. So it will drop off to bring your calcium level back up. And now albumin, now it's got less calcium, it will circulate to the bone, grab some more calcium to replenish itself. So one of the big functions of albumin, along with the capillary osmotic pressure we talked about, is to transport electrolytes around in the body. And this is really important. Albumin is produced by the liver, and albumin is only found in the blood. And the reason it's only found in the blood is once it's produced by the liver, it gets dumped into the blood, and because it's so freaking big, it can't go anywhere else. So if you got protein, you got albumin in your urine, you're in trouble, right? So albumin produced by the liver, dumped into the blood, and one of the things it will do is it will carry around electrolytes. One of the big electrolytes that it carries is calcium, and the liver produces that. And again, very important, when an organ fails, all the functions of that organ fail. So if the liver is failing, you're drinking too much, right? Not reading the textbook. You got hepatitis. That will affect the liver's ability to make albumin. So liver failure can result in hypocalcemia. All right? Okay. Now, again, we talked about total calcium. That's the amount of free-floating calcium, the ionized, plus the amount of calcium floating around in the blood bound to albumin. So I just explained that to you. All right? Now, here's another thing. You learned about the control of blood sugar with insulin, which lowers your blood sugar, and glucagon, which raises your blood sugar. Well, the hormonal control of calcium works the same way. And there are two hormones that are involved in controlling blood levels of calcium. The parathyroid hormone, and the parathyroid hormone, or parathyroid hormone, is released from 4 little nodules that surround the thyroid gland. And when you surround something, the medical term for surrounding it or around it is para. So these glands are around the thyroid gland. And the parathyroid gland releases, oddly enough, parathyroid hormone, or PTH. Now, you need to know this. Parathyroid hormone is released when the blood levels of calcium drop below normal. Now watch. If your blood levels of calcium are lower than normal, all right, and the normal blood levels of calcium are 8.5 to 10.5. Now labs will vary, but not by much. So that's a pretty narrow range. So if your blood levels of calcium drop below 8.5, what do you want to do? You want to bring up that calcium level back to homeostasis. So how and where is calcium stored, and how do you get calcium into the body? Now remember that the parathyroid hormone is released when your blood levels of calcium are low. So what do you think parathyroid hormone is going to do? Yup, you got it. It's going to raise the blood level of calcium, right? So where do you store 99% of your calcium? You store it in bone. What breaks down bone? Osteoclasts. You're not going to believe this, but parathyroid hormone stimulates osteoclasts to break down bone and then dump the calcium into the blood, right? The other thing, what controls all the electrolytes, the long-term electrolyte balance in the blood and bodily fluids? Well, that's right, it's the kidney. So parathyroid hormone is going to stimulate the kidney to bring more calcium back into the blood. So calcium will get filtered by the nephron, and then PTH, parathyroid hormone, causes more calcium to get absorbed back into the blood, right? You don't want to be peeing out the calcium if your calcium levels are low in the blood, right? The other thing it's going to do is it's going to stimulate the kidney to activate vitamin D. And you need vitamin D to absorb calcium from the gut, the intestines. All of these things make sense, right? Where do you get the calcium that you need? You get it from the stuff you eat. And in order to absorb it, you need vitamin D. Now, watch. What activates vitamin D? The kidneys. So if a person is in renal failure, will they be able to activate vitamin D? Nope. So people in renal failure have low vitamin D, and as a result, their bones tend to thin because they can't absorb it from their diet. So they got to maintain their blood levels of calcium, so that's going to cause their bones to thin. So that's one of the things you have to look out for as a nurse when someone's in renal failure, is they can develop osteoporosis. All right, so again, normal levels of calcium, 8.5 to 10.5 milliequivalents per liter, and parathyroid hormone is released from the parathyroid gland in response to a drop in the blood levels of calcium. And these are the ways that it's going to try to raise the blood levels of calcium. Now, what's the opposite of high calcium? Cut it out. So the other hormone that's involved in lowering blood levels of calcium is calcitonin. And calcitonin is released from specific cells of the thyroid gland. Now, calcitonin is released in response to an elevated calcium level in the blood. So if your blood levels go above 10.5 milliequivalents per liter, then calcitonin is going to be released. Now, if your blood levels of calcium are too high, what do you want to do? Right, you want to lower them, right? So what do you think calcitonin does? Watch. It stimulates osteoblasts, and osteoblasts build bone. So it takes the calcium out of the blood and puts it into bone, and that lowers the blood level of calcium. The other thing it does is that it inhibits the reabsorption of calcium back into the blood. So you're going to be peeing out more calcium, right? Why was calcitonin released? It was released because your calcium's levels were high in the blood. Now, do you want to be absorbing a bunch of calcium from your gut if your calcium levels are high? No. So calcitonin inhibits the activation of vitamin D by the kidney. Less vitamin D, less absorption of calcium from the gut. So these two hormones are critical, right? And one of the things that can happen in people with thyroid problems is if they get a tumor of the parathyroid gland, that typically causes hypersecretion or a lot of parathyroid hormone. What does parathyroid hormone do? It raises your calcium level, right? It raises it up. But if you have a tumor, it's going to continually secrete that hormone. And the function of parathyroid hormone is to raise your blood levels of calcium. So if you got a tumor, you're going to have a lot of parathyroid hormone circulating. That means your blood levels of calcium are going to be really high. So in parathyroid tumor, that causes hypercalcemia. All right, very important. All right, so watch. Parathyroid hormone and calcitonin work like insulin and glucagon, right? Insulin and glucagon control glucose levels. Parathyroid hormone and calcitonin control blood levels of calcium. And about 50% of that calcium in the blood is bound to the big protein, albumin, big L, right? And the liver makes it. And I just said this to you. Remember, when an organ fails, all the functions of that organ fail. So, if a person goes into liver failure, they can't make albumin, so the amount of albumin is going to decrease, and therefore the amount of calcium available in the blood is going to decrease. So people in liver failure develop hypocalcemia, low levels of calcium. All right? And then just real quick, calcium and phosphate work in opposite directions. All right? When blood levels of calcium are high, it will cause a drop in phosphate levels of the blood. So they are diametrically opposed. So what's the function of parathyroid hormone? It's to raise your blood levels of calcium. And one of the ways that it does that is in the nephron, in the collecting ducts. It will cause the calcium that was going to get peed into the toilet to get reabsorbed back into the blood. But PTH then also causes phosphate that was going to stay in the blood to get dumped into the urine, and then it gets peed out. So elevated calcium levels typically lead to a decrease in phosphate levels. All right? Okay. So that's a little introduction. Let's get into it. So I'm going to talk to you about hypocalcemia. So hypocalcemia, less than 8.5 milliequivalents per liter. Let's look at some of the causes, right? Hypoparathyroidism. So if there is just a decrease, and this can be idiopathic, meaning it just happens. And if you have low levels of parathyroid hormone, then that means you're going to have low levels of calcium because parathyroid hormone raises it up, right? In acute pancreatitis, I'll explain this to you right now. Right now, just take this on faith, all right? That pancreatitis will cause it. Acute renal failure will cause this too. Calcium has to be actively reabsorbed back into the blood. And when you go into renal failure, the parts of the organ that require energy, those fail first. So calcium has to be actively pumped back into the blood, and that requires energy. So acute renal failure will cause more calcium in the blood. And then if you recall, when we went over the acidosis and alkalosis, and this is in reference to the albumin bust. So if you don't remember that, you need to review that an alkalosis will cause hypocalcemia. And then a low vitamin D, right? People who, like me, because all I do is rock back and forth and make videos, I don't get a lot of sun. So exposure to ultraviolet light, sunlight, that begins the synthesis of vitamin D in the skin. Then that vitamin D goes to the liver, gets worked on a little bit, and then it goes to the kidney where it's activated. So low exposure to sunlight causes low vitamin D. And then liver failure, right? The liver makes albumin, and it's also involved in activating vitamin D. And again, when an organ fails, all the functions of that organ fail, right? So liver failure or kidney failure can result in hypocalcemia.